The remainder theorem states that if the polynomial p of x is divided by x minus c, then the remainder is the value of p of c. So if p of x equals x, 3x to the fifth plus 5x to the fourth minus 4x cubed plus 7x plus 3. We're first going to find the quotient and remainder when p of x is divided by x plus 2. And then we'll prove the remainder theorem in part B. So because we're dividing by x plus 2, we can use synthetic division. I'll put a -2 outside the box. And our coefficients align inside 3, 4, -4, 0, 7, 3. Bring down the first one and multiply. So we get a remainder of 5. So our answer will be 3x to the fourth plus -1. Let's just write that as a minus x cubed minus 2x squared plus 4x minus 1. Plus our remainder 5 over x plus 2. So part B said use the remainder theorem to find p of -2. So that literally means to plug in -2 wherever you see an x. So we go 3 times 2 to the fifth plus 5 times 2 to the fourth minus 4 times 2 to the third plus 7 times 2 plus 3. So 3 times 32, that's 96, plus 16 times 5, 80. Okay, I realized I was supposed to be plugging in -2, so that makes it -96. It'll still say a positive 80. It will go to a positive 32 minus 14 plus 3. So if we add all that up, we get 5. And the remainder theorem said that if we plug in what C is, we'll get the same remainder. And look at that, we did 5. We also have the factor theorem. C is a 0 of P if and only if x minus C is a factor of P of x. So for our example, we're letting P of x equal x cubed minus 7x plus 6. We're going to show that P of 1 equals 0 and use this to factor P of x completely. So let's work out P of 1. 1 cubed minus 7 times 1 plus 6. Goes to 1 minus 7 plus 6, and that goes to 0. Okay, that means we plug it into, this is P of C, so C is 1. So now we can set up one factor, x minus 1, and use synthetic division to find the rest. 1, 0, negative 7, 6 for the coefficients. Fill it in. All right, so that leads us to x squared plus x minus 6. And so we have now a quadratic. We can factor that to x plus 3 times x minus 2. Bring down our last factor. Our first one, actually, x minus 1. So we have now factored p of x. Now we're going to go the reverse, where we're going to find a polynomial of degree 4 that has the zeros negative 2, 0, 1, and 3. So we're plugging these, all 4 zeros, into factors, x minus c. And these numbers, negative 2, 0, 1, and 3, are c, so we need 4 of them. All right, so we go x minus negative 2 times x minus 0 times x minus 1 times x minus 3. So we got 4 binomials multiplying, so let's multiply 2 at a time. First 2, I'm going to go to x squared plus 2x. Second 2, I'm going to go to x squared minus 4x plus 3. Now we can multiply these two polynomials together. So we're going to get x to the 4th, 4x cubed plus 3x squared plus 2x cubed minus 8x squared plus 6x. So we get x to the 4th minus 2x cubed plus 5x squared plus 6x.